This is a demonstration video of the Forest Manufacturing Model 236 Heavy vertical blade traveling table bandsaw. This is a standard machine for us, although we have the ability to build these with customized table dimensions, and we can add lots of features to the machine. The basic Model 236 is a four-wheeled bandsaw. It's a high-speed machine. We're running a blade speed of 3,000 feet per minute, typical as what you might use for cutting plastic, foam, insulation, insulated or expanded polystyrene, drywall, wallboard. The machine is built using four 14-inch blade wheels, allows it to carry up to a 3/4 inch wide blade. We almost always provide these with pneumatic blade tensioning, so we use an air cylinder as the element to generate the force tension of the blade. That's in contrast with a screw over spring mechanism. This machine has the traveling table, so all the 236s have a traveling table. My standard Model 236 uses what we call a cantilever style table. It's great, easy to work with, works for work pieces up to about 4 foot long or maybe 100, 150 pounds. If you have a larger or a heavier workpiece, then we switch to this rail mounted table. So this machine has a table stroke of 96 inches. It also has our precision workpiece positioning fence to help locate your workpiece. The machine's actually about 95% complete, but I need to get some test cuts out. This machine has a powered variable speed table drive mechanism. So we can either have these manual traverse, so basically we put what I call a grocery cart handle right here and you manually push the table to make the cut. We also put a guard here. Or, like this machine, we have a variable speed powered table drive. If you're cutting something that's very heavy or just very slow cutting, certainly the powered table drive makes sense. It helps you get a higher quality cut. Even if you're cutting something lighter, having the powered table drive means you get a consistent feed, speed, and pressure, which results in a prettier cut. A human operator pushing a table, particularly with something slow cutting or heavy, he might jerk and move and stop, and that translates through to the cut surface. You may still be a straight cut, but it'll just look a little skew-if. When you have a power table drive, you set the speed and you know you're always advanced table same speed, you get a nice, consistent, pretty cut. And for the customer, the actual owner of this machine is doing just that. They're cutting large, bulky work pieces, which they could cut with a manual traverse table, but they want that pretty cut. So with a powered table drive, the operator will set the speed, leave it alone, hit the go button, the machine does the rest, you get an attractive cut. The controls, this machine has what we call our basic controls, and I don't think they're actually all that basic. Control cabinet, fuse disconnect, magnetic motor starter with overload for the blade drive motor, a AC variable frequency drive controlling the table drive mechanism. On the panel face, we've got table start, table stop, blade tension and detension controls. This machine, like I said, includes the pneumatic cylinder tension of the blade. The pneumatic cylinder is controlled here from the panel face, so you flip a switch, the blade detensions or retensions. We also include a blade breakage detector and a low air pressure switch. If you get either of those fault conditions, the machine stops and you get the fault light. Also, if the blade drive motor trips out, say you overload it, maybe you try to feed a big workpiece and push it in too fast, overload the blade drive motor, overload trips out, red light. If you have a fault with the table drive mechanism, the inverter, red light, everything stops. For the table drive, got a forward and reverse button here. With off, stops everything. I have two speed controls. I have a separate speed control for the forward and reverse directions. What's going to happen is you're going to find some speed, table advanced speed, to make the cut that works. I try to set these machines up so the table advanced speed is something like 20%, 10% of the machine full speed. So you'll set the table advanced speed control dial where it needs to be and leave it. For the return stroke, after you make the cut, when you're moving the table back to the home position, that is dead time in your socket. So you're pretty much always going to leave the return speed at 100%. So you got separate dials for that. This machine's got a few other things you can get. It will have, I mentioned that we're about 5% short of completion here. It'll have an electronic digital readout showing fence position. That's enough about the machine. The material I'm cutting today is actually a new one for me. I have a potential customer, bring this up where you can see it. I'm going to compare this to a structural insulated panel, but it's really a lot more than that. So I have a center core of EPS, I believe it's expanded polystyrene. I have drywall basically, and then I've got a thin skin of metal on both sides. Apparently it's a very thin gauge, presumably a roll-coated steel material. So I'm cutting 3 different materials at once. The limiting factor here is the steel. To cut through that very thin gauge steel, I need to use a very fine tooth blade. But a very fine tooth blade is going to take forever to get through the drywall material. The EPS is just going to kind of disappear in front of any blade. But the drywall, I use 2 final blades to take a long time to cut through that. So my compromise, bring a 3/4 inch wide, 10 tooth per inch blade. And I've done several test cuts getting good result with this. I'll give you a demonstration cut. I've got 2 pieces of this stuff. One I've been nibbling off of, same stuff. One I've been nibbling off of, here's my cut surface for reference, and I'll do another one for you. They assembled this from pre-cut pieces apparently, so I don't have, this edge does not have a good register. This is how they assembled it. Although considering that they hand assembled it from pieces, that's actually a really good register. This piece here is my cut edge. So I preset the position. You know, this stuff scratches easy. So this roll-coated material, it actually scratches pretty easy. Something to consider. I pre-position my fence. I'm using a magnet as a stop to prevent the workpiece from sliding backwards. I got another magnet in here just to keep it pushed up against the fence. I'll come over here to my control panel. A limitation of this machine, my control panel is over here. The piece I'm cutting is in there, and so I can't really see while I'm doing the cut. For the most part, you're gonna know what settings work. You're gonna load the workpiece, you hit the green button, and it's all to do the job. I do also offer as an option an upgraded control panel, where I have all the controls on a handheld pendant. So you can walk around the saw and view the cut from any angle while you're cutting. This machine does not have that option, but I've already made several cuts. I have a pretty good idea what settings are gonna work. What settings are gonna work? So I've got the table advance speed set at 1/2 inch per second, or 2 seconds per inch. Still pretty conservative. I think I can go faster than that. I've made a number of test cuts escalating my feed speed, trying to get something representative. I've only got so much of this material to play with. I didn't want to use it all up making cuts before I started rolling the camera. So here we are. I've gotten up to that 1/2 inch per second. I'm still getting a very good, perfect cut quality. I'll demonstrate. Start the saw. Start the table advance. I should be running dust collection, sorry about that. This will be loud. This saw does include provision for hooking a dust collection system up, and this makes dust. We come around and collect our prize. So here's the edge we just cut. Now I am getting, you can see here my sweaty shirt. It's hot in Houston right now. Getting just a little bit, little teeny tiny bit of a burr from this cut metal. That's from using, compared to the thickness of the metal, 10 tooth per inch is a relatively coarse blade, but it's the right compromise. Let's see here. Nice, straight, smooth cut. So the saw will do the job. You can also stack these work pieces up. Now, I don't have a whole lot of this to play with. I did some experience earlier. Tell you what, let's go ahead and do that. I can stack these work pieces up double high, but just don't have a whole lot of material to play with. I think I could stack these like 3-4 high easily. I just don't have that much material to play with, but I'm gonna double stack some of these skinny pieces I've made. Return the table to the initial position. Going to adjust my fence in a bit to get closer. And so I'm going to stack, I'm going to double stack this. Go a little further than that. Nope, wrong direction. That's good, that's good. Okay. Double stack these. I'm trying to figure out a way if I can triple stack this. I don't really have a good way to support it. I see something. I want to try and cut 3 pieces at once, just to see if I can. Yeah, this is a different thickness, that's not gonna fly. So these 2 pieces are cut for the same thickness, so I can run them at the same time. So another magnet here. It's a backstop, one to keep them pushed up against the fence. I'm gonna dial the speed back just a little bit. That's 10 hertz, so about 1/3 of an inch per second, 3 seconds per inch. Start the drive, start the table drive. See what we get. Dust collection. Sorry folks, it's turning into a bit of a long video, but for the potential customer, this is what they need to see. Taking it just fine. I probably could have gone faster. Took that just fine. I probably could have gone faster. Beautiful. Beautiful. So that's what it does. If you have any questions, please feel free to call or email me at Forest Manufacturing. Thank you.